the H file things that you want other classes to know about. Now, I say that this is private property, but the reality is that there really isn't enforcement of a lot of these notions of privacy in iOS. And indeed, a lot of the times when people are taking advantage of undocumented features of iOS, it's because they've somehow figured out that there is a foo method. And the foo method is this magical thing that allows you to tether your phone, for instance, wirelessly to a laptop. Because that functionality is there, it's just Apple's not advertising it in the SDK. So if you pass messages to an Objective-C object and that message is implemented, it will get called, even if you've tried to hide it from other people. So realize this is a design pattern that's a good convention to adhere to so that your partner knows shouldn't call this, so that other programmers know shouldn't call this. But the reality is that adversaries or very creative hackers can figure out that these things exist nonetheless. So it's not so much a security mechanism as it is a design principle, at least in Objective-C. Other languages like Java enforce this much more rigorously. All right. Lastly, I say strong here. So let's try to tease this apart slightly. So previously, when I had an IB outlet, it was weak. Now I've said strong. Why? Any thoughts on what weak and strong are actually doing for me? Okay. Charles? So it does. It has to do with this feature called reference counting, which Objective-C has underneath the hood and publicly had until last summer when Apple made programming easier for the masses by adding this thing called automatic reference counting, which recalled was that checkbox I checked. So at the risk of oversimplifying for today's purposes, know this. In none of our code yet have we ever called free, or the equivalent of dealloc. We've called alloc, but we never actually free that memory. And this is in stark contrast to C, where anything you mallocked, you then called free on. Well, Objective-C is a little more sophisticated now than C, whereby it keeps track for you of memory that you've allocated, and effectively, when it goes out of scope, it is freed automatically for you. But here's the problem. If you have allocated memory and you don't want it to go out of scope, because some number of seconds or minutes later, you might want to access that same array of words after the user has walked away from the device and comes back. In other words, the method that allocated that array has returned already. You need to tell the compiler, keep this pointer around. Do not let the OS reclaim, thus free, this memory. So by saying strong here for this property, this is sort of planting a stake inside of this object saying, don't let the OS take this away from me. I keep this resident in memory. Whereas weak says, keep it around as long as you like, but I don't really care if it goes away. Now, why the difference then between this and the IB outlet? So just intuitively, it's probably pretty reasonable to expect that if you declare an NS array and its purpose is to store words and you don't want them to go away, strong feels like the right semantics to use, right? Keep this around. As an aside, how is that implemented? Essentially, inside of every object in Objective-C, there's a counter that starts at 1 when it is actually allocated. All right? And then if you go out of scope, that count is decremented to minus one, so you go back down to 0. As soon as an object's reference count is 0, what do you think happens? The operating system frees that memory. It's similar in spirit to garbage collection, familiar with this term, but it's a little better in that garbage collection is often invoked non-deterministically once in a while to reclaim memory. Reference counting, when things go to 0, they're typically immediately reclaimed, which is typically better for performance, at least so far as the user is concerned. If then I allocate this array and it's by default 1, but can very easily go to 0 when it goes out of scope, by specifying strong, what does its reference count actually go to most likely? 2, which means even as it goes out of scope, it does get decremented, but that leaves it at 1, which means I still have a stake in that object, which means the iOS operating system is not going to take it away from me. Now, as an aside, had this course been offered a year ago, you would have had to do all of that plus oneing and minus oneing yourselves. And this was, I mean, frankly, it wasn't hard once you understand what's going on, but it was prone to lots and lots of buggy code and memory leaks. So in general, a good principle in compilers is assume you're better than the programmer and start to do as much of this for him or her, which is what the OS is now doing. But you still have to provide these hints to the compiler so it knows what's going on. If I did weak, this program could very well crash or just not function, and it might just happen once in a while because of the memory being taken away from me unexpectedly. And now, just as an aside, the reason that you use weak for an IB outlet is because the nib file will take, the nib file is the owner of all of the widgets that you've dragged and dropped there. So it has specified already that its own pointers to those objects will be strong. So you do not need to doubly say keep these around. You can assume that the nib will do that for you. And indeed, if you specify strong, you might be wasting memory, because if the nib, and this is an oversimplification, if the nib wants to give some memory back to the operating system because that screen is no longer in view because it flipped around, it can't do that if you've specified strong for the text view and the button and all of these other widgets. So your application could end up using more memory than it actually needs to. All right, so that's memory management in a nutshell. But we started with this, the notion of a private property, and the goal was simply to read in these words. So we'll take a break in just a moment. Let's just see which of the methods actually display this data. Because this class, my view controller, is implementing that table view controller now, because I've specified that it's the delegate of a table view, certain messages are going to be passed to it. And among them are just a few of the ones we saw before. Number of sections in table, table view, cell for row at index path, and then down here, if I scroll down ever so slightly further, table view, number of rows in section. So here's how this works. Recall in the nib file that you have this structure for a table, and it has two outlets, one of which is data source, one of whom is delegate. That just means, again, this thing, this UI widget, will occasionally send messages to the view controller asking for data or informing it that the user has touched something on the screen. Well, what method is it going to call when it wants to know how many rows it needs to make room for? It's going to send the message, table view, number of rows in section, and what do I, the delegate, have to do, or the data source have to do? I just have to answer that question. How many rows do I want? Well, I'm going to do self.words, which gives me my array, pass in the count message, it does what it says, that's going to return 5, or whatever it is, number of words that I have here. So that responds to that question dynamically. Up here, this is asking number of sections in table view. If you have an iPhone or iPod or iPad, you might know that some UIs, under settings especially, have little ovals of settings, and then there's a section heading and another oval of settings, and then a bold-faced header. They're sort of chunked into different sections aesthetically. This is just saying how many of those things do you want. I don't care about those aesthetics. You have one section, which means just give me a big, long view. So lastly, and the most interesting method is the one that answers the question, what should I show in row I? And to implement that method, I can do this. Table view, cell for row at index path. So how do I implement this? It's a few lines, but at the end, they create the effect of displaying everything. So when this method is passed, it's going to effectively be passed in the number 0, 1, 2, 3, or 4, if I've got 5 total rows. So when passed in 0, what happens? Well, first, I have this string here. I just need a generic cell identifier. This is for reusability of cells. Let's wave our hands at this for now. This thing here gives me a pointer to a UI table view cell, which is a little rectangle. This method here, DQ reusable cell with identifier, is this. Think back to your days of data structures, linked lists. Odds are the operating system, or in this case the SDK, has a linked list of available table cells, maybe 10 of them, maybe 100 of them. And if one is not currently being used by the on-screen display, it's going to grab that object and then allow you to refill it with whatever data you actually want to show. The motivation here being, if you have an iPhone or any device like this with limited screen real estate, and you actually have 100 entries in it, what things do you absolutely have to keep around in memory? Just these 10 rows. You don't need the other 90 rows kept around in memory. So the idea here is that as soon as you start scrolling up and one of those cells goes out of view, you can reuse that cell to display the thing down here as it comes into view. So it's a very clever way of not allocating 100 rows at once, but just 10 at a time and reusing them. So this method means give me an object that you might have allocated already, but that's no longer in use, dequeue it off of the linked list or the queue structure, and give me a pointer to it. If it's nil, that just means you don't have any lying around, so I actually have to call alloc. But once you have a cell, you can just do a couple of things. I can specify that the selection style is none. This is one of these crazy Apple constants, that are enums, that's super long name, but it does what it says. It means you can't touch on the cell. It's not going to turn blue. The next thing there specifies make the label, the text of that label equal to self.words, object at index, index path, row. So this is a little more complex than we need to care about today. Think of index path as just being 0, 1, 2, or 3. It's a little more than that, which is why we actually have to say, give me the row inside of that index path. To be clear, for those of you with iPhones, if you do have these sections where you have section heading and then row, that's what an index path is. It's a tuple like section 0, comma, row 0, so you get 2 fields inside of the object. But for now, just think of it as a row number, 0, 1, 2, 3, 4. And then that's it. You return the cell, and then the device knows to actually render that cell. So it's a huge amount of complexity, it seems, even though it gets much, much easier over time. But the motivation here is just very low latency. One of the things that iOS does really well is that even if you have a dictionary of like 240,000 words, it's actually going to be pretty zippy, even showing you all of those things on the screen, because it's generally only going to keep around enough memory for only 10 of them at a time. And it's much faster than the human's finger at reusing those to create this very seamless scrolling effect. Any questions? All right, so yeah. Good question. The strong property will remain so long as the parent object itself is around in memory. So if the view controller is deallocated, which won't happen in most of these examples thus far, then all of its properties will be sent a -1 message. So all of those things will sort of recursively be freed if their reference count goes to 0.
So if the application is going in the background, what happens to that?
Good question. If the application goes into the background, typically views will be deallocated. In other words, any UI objects will be freed, which is why you're going to need to reconstruct them from the neighbor and code. And we'll see an example of that today or next week. But things like your NS array will not be freed. If you've specified strong, backgrounding an application won't deallocate the object, but it will try to free up things like the views, a movie that's playing, anything that's fluffy and can be reconstructed but from code or a nib file. But an array, it would not be reconstructed automatically. So strong means keep it around.
So for like a game player, storing a game board, you can store it in the class, right?
You can store the game board if you keep, yes, if you keep the state of the board like a 2-dimensional array as a strong object, a strong property, then yes, it will stick around unless the user force quits the whole application. All right, that was a lot. Let's take a 5-minute break. We'll come back and start writing some 2D games. So what better motivation than this to implement pinching and gestures and swiping and zooming and such. So this is Tommy version 2, much improved over a version we did last year for a different course. And it will allow you, with your finger, to swipe through all of the awkward photos that I could find on Facebook for Tommy here. You can't quite see my finger, but as I'm in the simulator, but if you hold down Option, you can see what look like 2 finger presses. So we'll also see how using 2 fingers, you can actually pinch and make things smaller and bigger. So how to interact with this sort of application. Well, what's going on? So there are 3 total photos that I included inside of this project. So I constructed probably an NS array that contains maybe the file names of those 3 files. I've somehow registered an object as a listener, a delegate of sorts for these finger gestures so that you can actually respond to them if some message is passed. And I'm somehow distinguishing between left to right swipes and right to left, even though you can't quite see it on the simulator without my finger appearing. So how did I go about doing this? Well, this too is just a single view application. So I started with one of the simplest templates. And then I realized, all right, so if I've got 3 JPEGs, which I simply dragged into the app. So there is 1, there is 2, there is 3, and okay, very distracting. So let's take a look at where we always begin the story. App delegate, nothing interesting going on there. That's all the boilerplate code, just reformatted with some comments. This too is boilerplate. Application did finish launching with options. Who gets control? Looks like view controller class gets instantiated. Then we have viewController.h. There's really nothing going on in there except for this. Apparently there's a UI alert view. And indeed, if you click and hold, you will see that, for instance, if we click and hold on his nose, we'll see that he yells at you if you press down on his face too long. So how do we go about doing this? Well, viewController.m. So let's just get a lay of the land here. Okay, a bunch going on, so let's start here. So 1, let's pluck off the easy ones. This app apparently will only work in the portrait mode orientation. Why? Just because. I don't want to have to deal with rotating and resizing and whatnot. So I just hard-coded this return value to require that the orientation be portrait mode. Let's then scroll up. Init with nib name. So again, it's very often in these initialization methods that you won't do stuff related to the GUI, because that typically will go in something like view did load. But if you have some overarching initialization that has to happen, like loading images from disk or loading data from